So welcome everyone to the 2021 Elegoo competition kit of parts presentation. I'm going to be going over everything that's included in the kit of parts and trying to give a brief overview of what some of those components do. So the 2021 Waterloo Wellington First Elegoo competition kit of parts includes all of the essential items for competing. The primary components in the kit of parts are the Elegoo V3 smart car robot. Some students and mentors already have these, so if you already have one, then you won't get one of those. It includes the playing field mat. It includes 13 game pieces and a number of additional components to build an attachment for manipulating the game pieces. The things you'll need to supply this year are your creativity and then parts to build your attachment. You or your parents may have to pop out to Home Depot to get a couple of screws or some minor components. If you need to have parts 3D printed, there are a number of students on the various teams that are willing to assist other students with 3D printing of parts. So once we get the kits out, we'll probably create a stream on Discord for requests for 3D printing of parts. A few important notes about the Elegoo kit. The kit contains all of the tools and components that are required to assemble the Elegoo. We 3D printed a little wrench. Sometimes the nuts are a little bit hard to put on. So we 3D printed a little wrench. It's included in the additional kit of parts, but that should be everything you need to assemble the kit of parts and the Elegoo. There should be no need for cutting anything. The only thing that really needs to be done, or the most difficult part, is usually getting the protective paper covering off of the top and lower chassis. If you think you need to cut zip ties or make any other modifications, you're probably doing something wrong. There are some very small screws and nuts. Should make sure that you work on a table where you'll be able to see them when they fall, because almost definitely you're going to drop one or two of them. And if you're working on a carpet floor, you may never ever find those. There are lots of videos to help assemble the Elegoo kit. Most of these videos are for the Elegoo V3. We have the V3 Plus or older versions of the Elegoo kit. They're all very similar kits and the videos are still very relevant. So one of those is, I have a couple links to those. The last one is by a gentleman named Paul McWhorter, and he has a full curriculum of Arduino programming lessons in addition to the assembly of the Elegoo kit. And if you need more information, Google is your friend. And of course, if you have questions, you'll be able to ask them as well on the Discord channels. First thing in the kit of parts is the game mat. Do not fold it, it will crease. When you're finished with it or not using it, roll it in about a 3-inch diameter roll, and that way it won't flatten and crease on its own. If you roll it in a larger diameter, it tends to want to flatten out and it may get a couple of creases. It will mostly flatten out within minutes, but you may need to put a small weight on some of the corners just to help it along a little bit. The mat that you see here was rolled up, and it was less than 5 minutes after I unrolled it that I took the picture, so you can see it's already starting to get pretty flat. You'll be getting 13 game pieces, and there's two different versions of the mat, one with a red starting area and one with a blue. You'll get 13 cups that match the color of your mat. At least that's the plan. Try not to damage the game pieces. They are pretty durable. The Elegoo kits for competition will be controlled by some driver station software. The software is a Chrome progressive web application, and you can get to that by going to https://elegoo.wwfirst.ca/ds. That should run on any platform, whether it's Windows or Linux or your Chromebooks. It does require you to plug in a game controller of some type. If we find that students don't have a game controller and need to have another alternative, we'll find a way to release a touchscreen version that will have a simulated game controller on it. Your software for the Arduino that controls your Elegoo must include driverstation.h and use the driver station class. And that class just makes it simple. It's the one that communicates with the driver station and reports the game controller positions, as well as tells the Elegoo what game state you're in, whether it's pre-game, autonomous, or teleop modes. More documentation and examples will be provided in the next few days. The first component of the additional kit of parts is the ESP01. This device is a Wi-Fi gateway for the Arduino. The Elegoo kit normally comes with a Bluetooth module. We'll actually not be using the Bluetooth module. We're going to use this Wi-Fi gateway, and that allows us to connect to the Arduino from the driver station, and as well the integrated development environments wirelessly. So you don't need to connect a USB cable to connect or to update the firmware on your Elegoo. We've already preloaded the required software. There is a little bit of configuration required. There are instructions for that. And basically the configuration is to get it to connect to your home Wi-Fi. We will have a workshop to demonstrate how to connect it to the Elegoo. It's a pretty straightforward process, but there is one step that's a little bit more challenging. And so we'll have a workshop to go through that probably sometime next week. You have to use the ESP01 for competition because that's the only way that you're going to be able to communicate from the driver station to the Elegoo. And there will be a 3D printed enclosure in the kit of parts to protect it so that there aren't, so you don't short anything out. There is an extra HCSR04 ultrasonic distance sensor. This is a time of flight distance measurement sensor. Basically, it transmits a very short ultrasonic burst, 40 kilohertz, so you can't hear it. The little burst of sound will reflect off of objects and get reflected back to the sensor. And the Arduino can use the time between when it sent the burst and when it receives the burst to calculate how long it took, and then using the speed of sound in air, we can compute the distance. One of those useful things that you thought you'd never use from physics class, and it is really, really useful. It is the same as the one that's on the Elegoo, but has a slightly different connector. They're simple to program, and there are plenty of examples. Again, Google is your friend. We've included an extra SG90 servo. The Elegoo has a very, very similar servo in the kit of parts, or in its kit. The Elegoo servo is initially used to change the direction of the HCSR04, the ultrasonic distance sensor. And it has a range of about plus or minus 90 degrees. These are small servos. They're used mostly in RC cars and planes. And they have 3 pins on the connector, a ground, a power, and signal. The servo port on the Elegoo expansion board matches that pinout. There is an expansion connector that has all of the digital outputs from the Arduino, and that port doesn't match the pinouts for the servos. If you want to use that port, you'll actually have to reverse the power and ground pins in this connector. If you do that though, make sure you're very, very careful to always connect your servo in the right spot. You don't want the power and ground reversed because it could permanently damage the electronics in the servo. There's a very simple Arduino servo class that you can use to program it. And basically you set the angle by going my servo .right, or whatever you call your servo in your code, .right, and a value from 0 to 180 degrees. So centered would be setting that value to 90 degrees. We've also included a continuous servo. It's the same size, has the same spline on it as the SG90 servo. The difference here is that this servo can rotate forever in any direction. It's not limited to plus or minus 90 degrees. You still use the Arduino servo class to control it. The difference is writing a 0 to the Arduino class for this servo will make it run at full speed in reverse. Setting it to 180 will have it running full speed forward. And setting it to 90 degrees will have it stop turning. General servo rules: never turn a servo, or especially don't force a servo by hand. If you're going to turn the servo by hand, if you absolutely need to do it very slowly and very gently. There is a high gear reduction in the servo. So the speed that you're turning the input shaft, or it's actually the output shaft, will result in the motor spinning very, very, very quickly. And you want to be very gentle with them. These servos in particular have plastic gears, and with that high gear ratio, it is possible to strip gears. Pay attention to the torque specs. The 2 servos that we have are, I believe, 1.5 and 1.6 kilograms centimeters is a torque spec. That means that if you had a lever or a spool that was 1 centimeter in radius, these servos would lift approximately 1.5 kilograms before they stalled. If you put that on a 2 centimeter radius spool, it would be able to lift half of that, and so on. We have an Arduino IO Expansion board. The expansion board provides 8 additional inputs and or outputs, but it does use 2 of the signals that are used by the ultrasonic sensor in the default kit. Limitations. Since it uses I²C, that's using those 2 extra signals that would normally go to the ultrasonic sensor, the 8 digital inputs and outputs are shifted out, which means you can't directly set them in software. You have to set them and then they get transmitted to this device. So it takes a little bit more time. And that means that they're a little slower. You can't check them as often or as quickly as the internal pins, and you can't use them for interrupts. So there are a couple of the additional components that we'll talk about that you might want to use interrupts for. You can't connect those to the expansion board. There are several Arduino libraries available for communicating with this. I haven't had a chance to test any of those libraries yet. Feel free to test them, and if you find one that works well, post it to the Discord. I'm expecting I'll get a chance to play around with them in the next little while, and when I do, I'll post as well. We've also included a beam break sensor and two beam break sensors and encoder discs. The beam break sensor has that little U-shaped end on it that the disc would slide through, and it has a light emitter and detector on opposite sides of that slot. The encoder disc would rotate through that, and as the encoder disc would rotate through, you would get the light being visible and then occluded by the spokes in the wheel. Alternatively, you can just simply use these as a limit switch if you don't need an encoder for your Elegoo. To use it as an encoder, you mount the discs to the Elegoo motors. The center piece or the mount connects directly to the Elegoo motors, and you can do that on the opposite side of the wheel. There is a 3D printed spacer for the wheels or for the motors to make room for the encoder disc. And there's also a holder for the sensor in the kit of parts. You can use the encoder disc to measure distance or speed by knowing how many times the beam break sensor has tripped. And as I said, the holder for the sensor is included in the kit. In order to do this reliably, because you don't know when the wheel will turn to a point where there's now light or not light, you need to do these to have this hooked up to a pin that you can use interrupts. Otherwise, you might miss one of those transitions, and then you would lose track of either how fast you're going or how far you've gone. To use it as a limit switch, you just need to design your mechanism to break that beam, basically something that will slide between that U shape at the end when your mechanism gets to its limit, and that will signal your software, or can signal your software, that you've reached the limit of motion. And in this mode, you could easily use it with your with the expansion board. We've included two limit switches. They have 3 pins on them. One of them, one side of the center, you can see there's a C, an NO, and an NC on the side. The pin that's marked with the C is a common. Connecting to the NO would be normally open. So when the switch is not being pressed, the switch is open, and the normally closed would be the opposite. The switch is closed until you press the switch. They're useful for detecting limits of travel of an actuator, or they could be used for sensing contact with a game piece. And in most circumstances, you would be able to use those with the IO extender. We have a Rotary Encoder module. There's 2 of them in the kit. It uses full quadrature encoding. I'm not going to go into detail what that means, other than it allows you to count in both directions. The actual component is a KY-040, and if you Google that, you can get more information. And as I said, it can keep track of position, counting ticks both forwards and backwards, so it counts up and counts down, but it requires 2 pins per encoder. There are 40 edges per rotation, so you can tell within 1/40th of a rotation how far it's turned. There's a maximum speed of about 60 RPM, so about 1 revolution per second. If you go faster than that, it's likely going to lose track of some of the edges. And in order to work reliably, it's going to require some advanced programming using interrupts as well. You can use it with one of the signal pins, but then it's like the other encoders and you lose the ability to keep track of the direction of rotation, so you can't do a count up or count down. We're including 20 plus. I think it'll either be 22 or 22 to 24 of the DuPont cables. These are female to female cables. You'll get 10 that are 10 centimeters long, 10 or 11, maybe 12, and approximately the same number that are 20 centimeters long. There'll be random colors. And that's everything that's in the kit apart. Any questions? No questions. There has to be some question. Here's a good question. If parts get damaged, what solutions are there? We did order a few extra components. So if there are parts that get broken, you can speak to one of your mentors and they'll arrange to get a replacement part. Hopefully that doesn't happen too often, but we expect that there will be a couple of parts that either get damaged or may arrive non-functional. So if that happens to you, just get in contact with your mentor, with one of your mentors, and we'll take care of that. Nothing else? We're hoping that you'll be able to get your kit of parts early next week. And if you have any questions after you have the kits, please feel free to post questions in the Discord channel, and we will get those answered as quickly as we can. Another question. Can students add any other sensors if they want to purchase them on their own? In the rules, it specifies that the only electronic parts you can use are those in the kit of parts. So you can do anything you want with mechanical components for your kit, but you're limited to the electronic components that are in the kit of parts to make it fair for everyone. It looks like that's, oh, here we go. Yes, for further questions, yes, please use the Discord Elegoo Kit Help channel, and we will answer those questions for you. And I am going to, at this point, we will stop our streaming.